Hey everyone, welcome to Monday Live CAD. I hope everyone is okay and that you're having a nice day. I'm having a nice day, you can tell from my face. I finally shaved. um, Matthias, hello, how are you? How's everything? So since you're here, I was actually gonna talk about your lure turner because you kind of inspired me to continue working on mine, and we'll talk about that in a bit. So Matthias, I'm great. I'm also great. Thank you for asking. So Matthias made this lure turner from aluminum profile, and he's using. Wait, let's move it a bit. Yeah, so he's using this controller to control the speed. So it's a DC brushless, I think, or not brushless. I don't know. It's a DC motor. Um, that is high torque, I think. Wait, let's move things around a bit. And I have ordered one, which is a DC gear motor, high torque gearbox, reversible. So it's 7 RPM. I got the 12-volt version, and we already have all the dimensions, which is nice. And I also ordered a controller, but I got a different one because I want to be able to attach this switch and this knob on the outside. So I'm gonna put the UV station aside for now and continue working on the lure turner. Once the lure turner is finalized, then maybe we can modify the UV station to put it maybe around the turner or something like that. There are a bunch of modifications that I want to do. For example, I don't like this attachment right here. I don't think it's going to be sturdy unless it's glued, and I don't want to glue it. So yeah, I guess this one is for later, but for now I'm gonna focus like on the motor, electronics, and stuff like that. So we need to fit this thing plus the motor plus the fan. So I got 4 fans. I don't know if we need more than one. Maybe we need one for the motor and one for this thing. I'm not sure yet. We'll see. One thing that I don't have yet is a power supply. I still don't know how to provide power. I'm guessing, let me duplicate this tab. I'm guessing we need a mean well 12 volt, I think. Something like, yeah. So I guess I need something like this, 12 volt, probably like 25, 35 watts. I think even the 15 watt will be enough. It's tiny. Where is it? I think it's this one. 15 watts. It's small, so it should fit here, but I'm not sure if we need more than 15 watts. Now the motor is rated at, where is it? So this one right here, this is the maximum wattage it can support. The motor itself, I think, is 2 watts or 1 watt. It's nothing. I read it somewhere, yeah, 2 watts for the motor. And I think this is the maximum, but I don't think it's gonna use anything. Yeah, control power. I think it's about 6 watts. And we have the fans. That's it. That's all. So 6, 7, 8. I guess we can get like the 25 just in case. Do we have dimensions here? That's the thing. Did they put the dimensions? Is it 350? No. 75, 35, no. 25. Let's see. Cooling. output, input, protection, dimensions. 78 by 51 by 28, length, width, and height. Okay, nice. So assuming we're gonna use the 25, this is the dimension. Let's see the 15, it should be smaller, right? Yeah, 51 by 28. So it's the same width and height, just different length. 78. This is 62. It's gonna be parametric anyways, so we can move things around. That's fine. This is fine. So I'm gonna get rid of these holes, and let's see, motor holder. What did we do here? We can get rid of this mirror, or no? Wait, this mirror was for these things, I think. Yeah, this pad is the thing. This is something else. I don't know what this is. This is a interesting. Where are these pockets? Okay, right here. So we have these two. We need to get rid of these two. Sketch 6, we don't need it. So hopefully this will not break anything. Yes. We don't need sketch 6. Yes. And I don't need this mirror. Huh. So what's your problem? Wait, maybe we need to recalculate. No. Could not be created. The reason might be that the active body... Come on, I want to read you. Contains a base shape, so there is no material to be removed. Where is this sketch? It's right here. What do you mean, the base shape? Huh. So this is our base shape. Should be. But for some reason it's not working. Label pocket to refine through profile. Unknown sketch up to face offset. Recompute object, maybe? No. 3 settings, show description column. No. How do we tell this pocket to use this pad as the base? Because apparently it's not doing that. Let's recompute. Okay, so until here it works. The problem was after I removed the mirror. Right? Yeah. Yes. So if I remove the sketch, it's fine. Okay, it's this mirror that's causing the issue. Interesting. Very interesting. FreeCAD can be... Hi to all. Gregor, hello, how are you? Sorry if I'm not reading chat in real time. I'm a bit concentrated here. The following referencing objects might break. Are you sure you want to continue pocket 4? Copy selected. Add dependent object to selection. Oh, wait. If I delete the mirror and then I click, nope. How do I? Okay, wait. And so it's depending on the datum plane, but it's not depending on the pad. Interesting. Very interesting. Probably need to research this. FreeCAD. Let's see. Part design. Delete. Delete feature from tree. Something like this. Yeah. Save the file and load again? What? Saving and reloading did the trick. Interesting. Trying to check dependency on your producer. I'm still getting an error after deleting your feature. It would be much of a robust if you mapped sketches to standard datum planes. But I did that. All my sketches are on datum planes. Perform the recompute all and saved. After opening the recompute didn't show errors. I mapped the sketch to the standard planes, but the references are going as far as possible. I'm afraid to save. Maybe we can do a save as. Let's see. Experimental. Save. Let's see what will happen if I close and reopen. No, it did. Wait, no, I'm doing a recompute. It did not work. It did not work. But why? And now multi-face. Is it? Should it be reversed? No. Which pad is this? This is this one. This is this one. And then this should be these two. Oh, wait. Wait, let me close this without saving and go back to the original lure turner. So this mirror, or not here. It's the motor holder. Interesting. Okay, motor holder. This mirror is mirroring what is mirroring this pocket. We can basically just delete this and this. Okay. I mean, this mirror is doing nothing, but I think that's fine. This is fine. Nice. Now, Regarding the electronic box, I'm thinking of making it a different body, and then it attaches to this one using 4 screws or something like that. I mean, we could make it in less screws, maybe 2 at the top, and it slides into something in the bottom. But if I do that, then the printability of it will not be great. So anyways, I'm overthinking this. We need a new spreadsheet. Let's call it electronics box params, and we need a new body. We also need to rename this to electronics box. It's been a while since I worked on this project, so I need to remember all my parameters. So this one is in the middle, exactly right here. I think that's fine. Maybe we can move it back with a bit of tolerance. We had a general spreadsheet, right? Yeah. And it had tolerance. Okay, cool. Cool. So let's take this electronic box and move it in the X direction by minus general dot tolerance. Okay. Nice. So I guess we're just gonna create a box here. Hollow it out from this side. So what we need is the box. We need the box width or something like this, but we can also calculate this from the components. Let's for now do a box width. Do like, I don't know, 90 for now. Is gonna be box width input, and then here let's just make sure this equals to maximum value of BW input and give it a minimum value of 40. I don't know why, just to be safe. Let's set it to 30. I think it's fine. And then the thickness, I guess we can get it from the general thickness. I think we have it here. Yeah, thickness 10. Nice. Cool. So let's create a sketch here on the XY plane. Why are you looking at it from this side? Should be this side, right? Yeah. We want a centered rectangle here. Cool. Now this is going to be general dot width, and this one is gonna be, come on, I'm not clicking the buttons. So general dot, is it height? Yeah, it's height. Makes sense. Nice. And now we need to pad it by reversed. Okay, reversed by electronic box params dot box width. Cool. So let's hide what we don't need at the moment, like this moving platform. We're not working with it. The screw, bearings, the other screw, the lure holder, base plate. We're not working with it, so yeah. And I'm gonna also hide this just for a moment. We're gonna start by doing a thickness and adding this face. We need the thickness inwards, and it should be general dot thickness, something like this. We can give it its own thickness. Maybe 10 is too much, especially because we need some holes for the fans. I'm not sure. Let's leave it like this for now. Or you know what? No, I'm gonna give it a thickness right now. Maybe thickness and maybe bottom thickness is different. No, thickness overall. Let's make it something like 4. I think 4 is enough. So this is gonna be T input, thickness input, and here we're gonna give it a min value of, so T input is our input, and we're gonna give it a min value of 0.5. That's our thickness, and we're gonna go back here and let's change this from general to electronic box dot thickness. Nice. So let's make it red like all the other ones. Cool. Motor holder. So for the motor holder params, we have a motor diameter that we need to set because this one is different. What is the diameter? It's 37. It's a lot. Oh, what happened here? Model offset from top. Okay, so this is 37. Okay, and we can move it down if you want. This is the offset from top. It's set to 5 at the moment, but I think for now it's fine. It is fine. But do we even need it to be like that? Because do we need it like this? Because we might need to screw in these screws somehow. Yeah, like this picture. So we might not need it like this. I keep going the other way. Or we can do what Matthias has done, which is we will put the motor into something and then hold it in place here. But we have to screw. So the difference between my design and what Matthias has here is, I think in his design you can unscrew this part, move it like back, and then screw it again. So you're basically pulling the motor in. You did a press fit. Remember that the axle is not centered in one of the directions on the gearbox. Oh, that's a good point. Whoops, what did I do? Yeah, that's a very good point, because if we go back to our screw or the lure holder, I'm assuming that this is in the center, but it's not. So we need to modify that. It's right here. I think we need to lift it up somehow. Now they gave us the dimensions of these screws, or not the dimensions, basically where do they sit, like the offset from the outside. But is it just like a radial array? I don't think so, because the distance between this one and this one is bigger than the distance between this one and this one, I think. These two are mirrored, these two are mirrored, these two are mirrored. but I don't think it's a radial array. Anyways, I'm thinking ahead. I should not do that. Okay, so for the motor params, we're gonna need more information, not just the motor diameter. So we don't need these though. I think it's safe to delete these. Screw hole diameter, wait, screw hole distance, screw hole angle. I think they are safe to delete, yeah. Let's delete these two and these. Nothing broke. Nice. Yeah, one screw to slide one of the ends. I first forgot to take the non-centered axle in consideration and had to reprint one part. I might be able to do some measurement if you want some more than the one you got. I think we don't need all the screws, because what I'm thinking is to do something similar to what you have. Okay, where was it? So similar to what you have, which is I will put the motor inside something that will hold it in all directions. But my only problem is that there's gonna be a force. Wait, let's go back here. There's gonna be a force pushing the motor inside the gearbox. So that's why I need to screw it in. But I think that these two screws should be enough, and I think these are centered. So these are easy to model. So we have 31 from the center to the other center, and the centers are basically symmetric to the center of the circle, so they are easy. We can do that here, but first, that's our motor diameter. It is correct, but we don't want this to be the actual diameter of the motor. It should be smaller. What else do we need? So we need the motor diameter. We need the hole, the screw holes. We need the offset. This offset from the top, and I think, is it here somewhere? No, it's not. And this is 6 mil. This is 6 mil. This is 15. The offset is not here. If you can get me the offset, that would be great. But again, this is parametric. It doesn't matter. I can just set it here. Motor pin offset, something like this, and maybe set it to 3, and I can change it later. We have the screw. What do we want to call this? Distance between screws, something like this. Like distance between screws, and let's say it's exactly 37. So this one is gonna be motor pin offset input. Am I doing too many validations? Are these necessary? Maybe. Motor pin offset input, and the minimum value is maybe 1. And this is our motor pin offset. Distance between screws, input. Again, just a quick minimum value of 1. And this is the distance between screws. Cool. We have the motor diameter. We need the screw diameter. Screw diameter. I'm gonna call this one a 3 mil, but I'm not sure. So this is a 6 mil. I think it's an M3, but we can change it later. Screw diameter is 3. Maybe we need a tolerance here, but I think I'm gonna use the general tolerance. So screw diameter input. Again, just a quick minimum value. 1, maybe 0.5. And this is our screw diameter. Nice. Okay, so we need to modify this. First, I need to know how smaller will this be? How smaller than the motor it will be? And second of all, how smaller it will be? Oh, okay. Okay, I got it. I got this. So I'm gonna take let's hide the electronic box. Yes, we do need to know how small it will be. And that's gonna be, maybe we can calculate it. So we can say, okay, we'll take the motor diameter, remove from it the screw diameter multiplied by 2, so 1 screw on each side, and then maybe remove from it 2 mils. Will this work? Huh. Screw here. Do you think it will interfere with this thing? So what I'm thinking is, we'll modify this in a bit. We'll go back to this sketch right here and make it smaller than the motor diameter, but first I need to give this an actual alias. So I'm gonna call this a small motor diameter. Just got a pizza delivered for late dinner. Nice. I love pizza. Motor diameter. No, what did I call this? Small motor diameter. Why did it not show up? I don't know. So this is gonna be smaller than the motor. And then let's hide this for now. And then I'm gonna go from the back. So basically we need the datum plane. Do we have one? We have one right here. We have one right here. Oh wait, the origin is at the back. Yeah, I don't need a datum plane. Cancel. Create a sketch. Oh, come on. What? I don't have anything selected. Oh, I have electronics box selected. Okay. XY. And we want it from the back. And now I can draw the bigger circle. Diameter of this is motor holder params dot motor diameter, and we need to constrain this by general dot height minus motor holder params dot offset from top, and we need to also remove a radius, right? So motor holder params dot Motor diameter divided by 2. Yeah, cool. Cool. So now we can pocket this, but how much do we pocket? I don't want to remove everything. So we need to leave some material. And how much is this? So maybe we can add it here. What do you want to call this? Motor holder thickness, maybe. Let's make it a 3 mil. So this is gonna be MHT input, and this one will equal to MHT input, and the minimum value is 1. And this is going to be our motor holder thickness. Nice. Okay, so the pocket here, we need to go in by the general thickness minus the motor holder params dot motor holder thickness. So this will leave us with 3 mils. Now we can add the holes that we need for the screw. So another sketch right here. Now I'm thinking we need to also maybe extrude something here to support it even more, but for now that's it. I forgot to add tolerance. I'll add it. So we have 2 circles. These 2 are equal, and these 2 are also symmetric on the z-axis. Symmetric. Okay, cool. And the distance from here to here is our motor holder params dot, what did I call it? Distance between screws. Okay, that's very interesting. Oh, it's 31, not 37. Okay, close. Distance between screws is 31. And also we have this sketch right here, so this has to be bigger. So we need to add general dot tolerance multiplied by 2. Okay, cool. Something is wrong though. Wait, if this is 31, let's first measure this. Okay, we're gonna dimension this to be motor holder params dot screw diameter, but this is gonna be a hole, so we need to add 2 times the tolerance also. Okay, so I think I miscalculated this because I assumed that, where is it, motor holder times 2, yeah, I assumed we need 1 mil on each side, but of course we don't. So this 2 shouldn't be hard-coded. It should be a value that we calculate. We'll do that in a bit. We need to also remove general dot tolerance multiplied by 2. And here for now I'm gonna set it to 4, but we'll see. Oh, come on, it did not save. What? We will see. I can calculate this because I know that the distance from here to here is 31. If I add the screw diameter, then I know the distance from here to here, the entire thing. So yeah, I can definitely calculate it. Or if we remove, okay, so I know this is 31. If we remove one diameter, then we're basically from this edge to this edge right here, and then we can remove something. Yeah, I think that would have been a better approach. So this is our small diameter, right? So instead of doing this, I'll take the distance between screws. Oh, come on. Minus screw diameter, not multiplied by 2. Now I'm gonna have 2 mil on each side. So I'm gonna have 2 mil from here and 2 mil from here. But the only issue now is this here. So probably I need to cut something here for it to fit in. Just gotta be the 37 minus 31 divided by 2 for the inner small hole. So you're going for the bigger diameter minus the smaller one. Oh, minus this 31. Okay. And then divided by 2. I think this is fine because I want to be at least like 2 mil of material on each side. Now this is, as I said, this will interfere with this. So, and I'm guessing this has a big diameter that's also protruding outwards. Yeah. So what is the diameter of this? We don't know, but it's fine. We can add it as a parameter. It's 6. It's going. This doesn't matter too much. Maybe if we need to model this, then it does matter. But for now, I'm not gonna model it. Yeah. So I'm gonna have to cut something here for sure. Now, setting the y distance is exactly what I did before. Just set it to the general dot height minus motor holder params dot motor diameter divided by 2 minus motor holder params dot offset motor offset from top, and it's gonna be dead center. Okay, cool. Now we can cut these, set them to through all, and reverse it. Yeah, I get what you mean. Okay. Now let's do this up here. So we have the motor pin offset. Let's get the motor. I'm not gonna call it pin diameter because the pin diameter is 6, but I want this part right here. I'm gonna call it the pin holder or something like this. Let's call motor pin holder diameter. That is gonna be, let's say it's 8. I think it's more. Yeah, it's definitely more. It's 10. and this is gonna be MPHD input, and the value for this will be MPHD input, and minimum value is 1. Cool. So now we need to offset it up somehow. Oh, come on. This is just a simple circle. For the diameter, it will be, what did I call it? I called it the motor pin holder diameter. But I want to add tolerance. Cool. And the exact same, not the exact same, no, it's going to be different. So we're going to use the previous formula, which is the total height minus the diameter, motor diameter divided by 2 minus the offset from top. Okay, but we're gonna add the motor pin offset. Yeah. So this offset is obviously wrong. How much did I... Motor pin offset, I offset it by 3. It's definitely more than 3. I think it's like 8 or 10. Yeah, something like this. Let's call it 8. And now we can take this sketch and also pocket it. We could have done them in one sketch, but that's fine. Through all reversed. Nice. Cool. So it took me an hour to do a couple of holes. Yeah, so what else? What can we do to... I mean, I probably should do something like this to house it on the inside. But for now, I'm going to leave it at this. Maybe we can do something else. Get something else completed. Probably think about where we need to put this. The power supply and the fans. Let's start by... Here's our electronic box, and let me give it a bit of transparency just to see what's going on. 25. Cool. So I guess we can put the power supply back here facing downwards, and then, or it could be facing upwards, it doesn't matter. Yeah, it could be facing downwards so that the cables will not interfere with the airflow, and then the cables will go down, and there's gonna be the electronics, not the electronic, the this board, we can mount it right here below the motor, and this way we can mount one fan up here to cool the motor, and then one fan down here to cool the circuit. Probably the fans will be on the opposite side, not this side, and then something like some sort of an exhaust back here. And then here on this side I can put these two switches, one to turn on and off, but we have one more problem. How do we get input? I think I need to purchase something else. What is it called? AC input adapter or something? No, not this, not adapter. No, not this. 3-pin input, I think. I'm looking for that thing on like the back of a computer. That you plug a cable into to provide power. I think 3D printers like the Ender 3 also have it. What is it called? Ender 3, wait, power supply, I'll show it to you. Oh, come on, power supply. What kind? I'm looking at this, yeah. I'm looking for something like this thing right here. I remember I found it at a AC connector, maybe. Oh, come on. Yeah. Man, search is an art. I think these guys sell a bunch of stuff. Let's see. Probably this one. Yeah, so we need to put something like this somewhere here on the back. And then the input from this is gonna get connected to the input of the power supply. So we can turn this on and off from the back. Now this will provide power to the entire thing, to the board. But the board itself has another switch. This one. We also have the dimensions of this, which is nice, which is off, forward, and reverse. So we have two things. But anyways, I think I need to purchase this. So let me. Which one though? What's the difference? Oh, this one is already wired. Anyways, I'll check it later. Do they have the dimensions of it? AC inlet. I think this is what we're looking for, right? Yeah, we have dimensions. Cool. Cool. So what do we want to work on first? Let's see. Do we work on the board or the power supply? I think we can start with let's put the power supply here just to have an idea about the size of the thing. So going back to the power supply, which is here, let's make a box that is 78 by 51 by 28. So I'm gonna go to the electronic box and let's see. Let's call this power supply here, this section, and let's start by power supply width. I'm not gonna validate this for now just to be quick. It's length, width, height. So width is 51. Power supply length, it's 78, and power supply height It's 28, I think. Yeah. Cool. And put it here. Height. Put it here. Cool. So we need to create a new body in part design. We're gonna call it power supply, of course. And this one is gonna be a simple additive box. Wait, what? It wasn't active. Interesting. Add an additive box. So length is gonna be electronic box params dot power supply length. Width, it's going to be dot power supply. We're doing the width, I think, yeah. And height. Nice. Okay, but let's attach it to the YZ plane. And how is it looking? And we want to rotate it around x-axis, right? Apparently not. Y-axis also not. Around Z by 90 degrees. And then we want to move it this way. Interesting. So this thing right here, and that's the width divided by 2. So that's electronic box params dot power supply width divided by 2. And now where is it exactly? Where is the 0 of it? Okay, we don't have transparency on this thing. Hide the motor holder. Okay, it's exactly on. It's starting exactly on the 0. So we need to go back by tolerance, or we don't need tolerance. Let's just do the width minus the thickness. So that is the Z direction. Yes. So we need to go by minus electronic box params dot I called it box width. Okay. Anyways, plus electronic box params dot thickness. So it should be. Where is it? Okay, it's here. I don't know why it was doing that. It should be right here. I don't know why I didn't move the origin. I usually move the origin. Anyways. Yeah, I think I should have moved the origin. That's a better practice than this. So I'm gonna cut this, clear it, set it to 0, and then I'm gonna move the entire thing in the position, and this time the x-axis. So right here, I'm gonna set the exact same value, and now it should be here. And it should be exactly 1 tolerance away from the thing. Nice. Now I can move it in the Z direction. So at the moment it's down here. We want to move it up by, that's an interesting equation, because we want to move it by this distance here. General dot height minus electronic box params dot thickness minus the electronic box params dot, what was it, power supply length. And now it's exactly up here. We should probably move it down. So this is gonna be our power supply here somewhere. We'll figure out how to attach it later, probably some screws. But before we do that, I think at least a tolerance, right? Okay, so the wires will come from here. We have lots of space down here. We need to put the motor here. Oh, will the motor interfere with this? But again, we can increase the width. We can make this like 120. Make it big, thick. So that's fine. I'm thinking I don't want to attach anything to this other than the motor. Oh man, it's gonna be tricky to disassemble this. Because if the motor is attached to this, and let's say also the circuit thing is attached to this, and we have some screws here, so we unscrew them, we want to check some issue with the power supply or something. We have all these cables connected to the motor and we can't just like put it out. So maybe the motor shouldn't be attached to this. But again, I'm overcomplicating things. I can also make some sort of a door here that can also open with a screw or two. Anyways. Yeah, let's start with something simple. Yeah, we have the dimension for this, for example. Let's call it, oh wait, before that, we need this. Where is it? Okay, here. Inlet. I'm gonna call it inlet. Thank you, Matthias, for the names. So inlet, and let's say, what do we have? We have width. Let's call this length, or actually, yeah. Oh, we have so many stuff. 25 is from, interesting. So if this is 27.5 and this is 30.8, then minus 27.5, wait, what? No, minus. We have 3.3 here. And how much do we have here? We have 50. And here's 747. Why do we have 3 mil on this side and 3.3 on that side? That's stupid. We can have 3.3 on both sides. It should work. No, 3 on both sides would work. This makes things easier. One of the images are suggested holes to put in, bottom right. Yeah. So this is suggested hole for what exactly? Big Le Bob 1, hello. How are you? Anyways, we'll get to this hole in a bit. For now, I'm a bit confused about... I think the bottom here, this is not a hole, this is the border radius. I think that's the border radius. So this is the center of the circle, basically. And the radius is 3 mil. We call it fillet in CAD. Border radius is in software or in UI. But yeah. Anyhow, we have the thickness, right? Yeah, the thickness is 3.3. Anyhow, I don't care about how much it goes in. I'm gonna start with the outer stuff. So inlet, let's call it inlet width. And then we need the inlet length. So we know these values, which are 30.8. And we know that it's... But do we even need that to create a hole? Unless I need to model the entire thing. We don't need this, we need the inner. So I'm not gonna model the entire thing. So that's gonna be 27.5. The width, and the height, it's 47, or the length. Maybe I'll model it later, but for now, I'm trying to save time. So 47 by 27.5, there's a border radius. Do we need it? And this border radius, it's on the outside. Or is it also the same on the inside? Also 3. I'm gonna consider it's 3. But usually in CAD, if you have like an inner and outer radius, you need to subtract the distance between them. So if this one is like 2 millimeters away from this one, then this is going to be 2 mil smaller. But I'm assuming here it's the same radius. I think it is. So it's just 3 mil. And inlet fillet 3. Inlet width, inlet length, and the fillet. Come on. Where's FreeCAD? Where are you? Oh, oh my god. Don't tell anyone. The bottom right are with adjusted tolerance, so oh, 47.3. Okay, I see what you mean. I see what you mean. So this is 50, but they are suggesting to make a hole that is 47.3. So we don't need to add any tolerance. We need to just take these values as is. Put them here. 47.3. And then this one, 27 point... What was it, 8? Yeah. Okay, so the tolerance is 0.3, not 0.2. Or actually it's 0.15. Yeah, these are the clips, I can see them. Bottom left. Interesting. So we need to add a hole for these clips. I'm guessing. And what is the A value here? Yeah. Nice. So we have 1, 2, we have 4 clips. But where are they located? I can't get it. I don't get it. They don't have the location of them. Is it like a general thing at the beginning? Which one were we working on? No, that's a different thing. This one. Anyways, I'll check the clip thing later, I guess, or when I get them. But I mean, yeah, we can also have them as parameters and modify them when I get them. For now, let's just model something. So it's gonna be here. We need a datum plane for that because the origin. No, we don't need a datum plane. Nice. The origin is right where we want it. So right here, look at it from the back or the left. And we wanna put it here somewhere. Cool. Wait, what? How did this happen? Oh wait, I'm in the power supply. Oh my god. Okay. We do need the datum plane. So let's create one. Attach it here, and in the Z direction, is it negative? It's negative. It's gonna be minus electronic box dot box width. Okay. So now we can model this right here. So we're gonna start with the what did I call it? Length, electronic box dot inlet length, I think, and this one is the width. But I think I must add a tolerance. They are suggesting this tolerance, but so they are suggesting the hole to be exactly 47.3. But with 3D printing, I need to add the 3D printing tolerance. So I think, why is it 47? I didn't change it. Interesting. 47.3. I think it should be plus general dot. What is this? Lure Turner? No. General dot tolerance. I'll test this out. If it was too much, then I can remove it. And now, what do we need to do? Oh wait, I should have done the fillet first because it will break all of these. Yeah, it's gonna break them. And FreeCAD. So all of these are equal. And for the border or for the fillet, you need to use a radius. That's the inlet fillet. So now we need to do exact same thing we did. Electronic box dot inlet length plus general tolerance multiplied by 2. What happened? Okay. And from here to here. Okay, cool. One more thing is we need to know where to place. Wait, what? Oh, come on. I also lost symmetry because... Okay, now we're fine. So we need to know how high is it. And electronic box. Let's do an inlet offset from bottom. 15 or something. Sounds right to add your tolerances. Yeah, the printer tolerance must be added. Inlet offset from bottom. We can use that to do this. And basically this is going to be the thickness plus inlet offset from bottom, because I want the offset to start from the actual bottom, which is here. 15 is maybe too much, so let's do, where is it, electronic box, let's do 10, 1 centimeter. And now we can pocket, reverse, and to first, so that if we add something here later, it doesn't affect it. It won't anyways, but just to be safe. So I think we have enough room for everything. Might be able to shrink it down even a bit more. We need to add these holes, but I still don't know how. So how are they supposed to go in? Should the hole be like exactly the size of this box in terms of like width and height? There's not, there isn't any information about it. Anyway, let me add this. I don't know why I'm excited to add this. It's 15 by 21. And I'm assuming this one goes from, so we like thread the cable from the outside and then like press fit it in place, or how does it work? I've never done any of this. I think it also has these clips on. It's 15 by 21. Let's come here and let's call this the motor switch, or let's just call it the switch. So switch width and switch height. It's 15 by 21, and let's call this length. And we want it to maybe we need the recess for it. I think if pushing in the inlet onto a sheet metal, the clips would hold on the back side, folded in by pushing until fully inserted, but the distance seems very small between them and the lip. Yeah, so what we can do, I guess, is make this thinner, similar to what, wait, let's hide it, similar to what I did here, something like that. So yeah, maybe even thinner than this. So we push it from, let me close these, we don't need them anymore. So we're gonna push it from the outside, right? So we need to cut from the inside. Let's do this real quick. Inlet, inlet holder thickness, something like this, and let's make it, for example, 1 mil, and then we'll go from there. Where is that datum plane? So we can create another datum plane, and in the Z direction we can go by electronic box dot thickness. So I'm gonna draw here. I want to draw a box that is bigger than this one. Maybe we can add so thickness. Maybe if there's a mount, if there's one mounted by screws, fits better. Do you think? You don't want it to move when plugged in or out. That's a good idea. So basically you mean this instead. Wait. But is this even an option? I don't think they're even selling it. There's this, but it doesn't have an on-off switch. And a fuse. I think the fuse is more important than the on-off switch. Yeah, this one, for example, I think is a good idea. Interesting. It's this one, right? Might be easier than having a thin wall to allow clip. That one might be good. Yeah, the thin wall is not a good idea. That's true. Because it looks like it's just a couple of mils, like even 1 mil, which is not strong enough. This one is rated at 10 amps. Okay, cool. It also has a fuse, 10 amp fuse. This is AC01 copper, which I think it's this one. We have the distance between the screws. I think that's all we want. So we just need 2 holes to put 2 screws in, and then 2. Okay. So we don't want all of this. Maybe we can leave this, but no. Where is the backside? Oh, here's the backside, I guess. Okay, this sketch is super confusing. This is 65. I guess it's the entire thing looking at it from the side. Okay, so it's 47. The height, and then 27.4. 47 by 27.4. 47 by 20. Okay, so it's the exact same size. I guess I can leave this hole as it is and then just add 2 screws. So the screws is gonna be 3.6. It's a 3.6, so that's an M3 screw, and the distance between the two is 56. What is this? Is this 0.6? No. 56, 60? I'm assuming, let's assume it's 56. So we already have a distance between screws here, right? Let's say inlet screw distance 56. Let's go back to our sketch, our pocket right here. We can modify this because I don't feel like redoing everything. And we can quickly add this right here. So this one and this one are horizontal. And then we're gonna take these, make them symmetric. And then these are equal. And we need to define let's say it's an M3 screw, so inlet screw diameter, and then the distance between these two is gonna be electronic box dot inlet screw distance, and the diameter of this inlet screw diameter, and tolerance multiplied by 2. Yeah, now for the nuts, I need to add 2 nuts at the back. I guess I'll add them later because I need to do it in a way where it's not too thin. It's doable. I can add a bunch of material here and then put the 2 nuts. Now, for this switch, where do we want to place it? Oh wait, I need to think about how to mount. How do we want to mount the... We have multiple things to mount. We need to mount the circuit somewhere. I'm guessing probably around the walls here somewhere. And how does it connect to the motor? Let me just check real quick. It connects to the motor by using a bunch of wires, so that's fine. It doesn't have to be like near it. So we can probably just connect it on this wall right here. So we're gonna have something that goes in, Maybe we can put it here somewhere, and the switches will be down here. Or no, I want the switches to be in the middle or high. Down here, it's like a weird position. And then the motor. That's why I like to model the actual thing like this. Meanwhile, power supply. But I didn't want to model everything because I want to save time. Let's model this thing. I think we have dimensions. Not here though. Where is it? Yeah. It's 47 by 64. And do we have a schema for the holes? Nice. We don't have it. We can measure it once it's here. 74 by 46. So switch. Let's call this the board. So should we have the board width? We have the board length, and let's get a board height or thickness. So width is gonna be 46, 74, and let's say it's 2 mil. By the way, I think FreeCAD, they are introducing something other than spreadsheets that's supposed to have even more functionality. I guess that you could bypass the board power switch and only use the inlet switch if you want to. Yeah, we can do that. We can do that. This gives the only benefit that this switch will give is the ability to go in reverse direction. Like if you want it to be clockwise or counterclockwise, I think that's it. You can turn it off, like you can temporarily turn the motor off without cutting power from the power supply. Also, you can do that because I don't know what will happen if you power it off and then on. I guess it will resume on the same speed, right? Because I'm guessing this is a, what is it called, a potentiometer or something, this resistor with adjustable resistance. I'm guessing that's that, so should be fine. So we can definitely bypass it, but I'm gonna leave it as an option. Potentiometer, yeah. Yeah, so this has 3 options. 0, it will turn off the motor. 1, I think it's like forward or clockwise, and 2 is like counterclockwise, something like this. Yeah, it should run in the same speed. Board width, board length, board height. Okay. So let's create a new body and let's move it somewhere. Currently it's right here. I want to put it on this face. So on the Y, negative Y, I want to go by minus electronic box parameters dot width. Did I? No. This is not the, this is the general width minus the electronic box parameters, or since we have a minus, it's going to be a plus. Electronic box params dot thickness. So it should be width divided by 2, since we're in the center. Cool. Now we can move it up. Let's for now put it in the middle. So I'm just gonna go by general.height divided by 2. And then also put it in the middle of electronic box params dot, I think I called it box width divided by 2, and it's negative. We'll move it if it didn't fit in here. So we need to create a new sketch. Is it active? It's active on the XDZ plane. Okay, cool. I think, let me think about these. So this is gonna go, yeah. I think this is gonna be the length. And then this one is gonna be dot board width. Is it this big? What? It's bigger than the power supply and the inlet? Interesting. Very interesting. And now we need to pad it in the opposite direction by board height. Now I messed something up in the Y direction. I want to also add a tolerance. Did I add an underscore? Whoops. How did... Oh yeah, I want to add that's a plus. Yeah, that's big. It's bigger than I thought. Maybe we can move this power supply to the left. But will it affect the motor? No, it shouldn't. So if we take the power supply, on the Y, it's currently in the center. So we want to move it by... I want to move it in which direction? The positive direction. I want to move it by general.width divided by 2 minus electronic box params dot thickness minus electronic box params dot power supply width divided by 2, I think. What is wrong? It's this. Okay, and we need some tolerance also, so minus general dot tolerance. I guess this is how it will look like. Yeah, the switch then can be up here, the switches. And the fans can be here. Do we need to also cool the power supply? We're gonna need an exhaust somewhere. So maybe the exhaust goes through the power supply. We have the dimensions for the fans. 40 by 10. So this one is our board. Let's call this fan 1. And then here, fan width is 40, fan length is 40, and fan height is 10. Cool. So fan 1, we need to move it here somewhere, but first, it's not very much amperage drawn, so if you have one fan and another port, it all should be just fine since the air circulates. Yeah. Yeah, more about, I mean, I don't know about this specific motor, but I have used this one before, and maybe because this one was like a 220 volt and this one is 12, or the one we're using right now is 12, but this one used to get super hot, like super hot. You can cook on it, and that's why I'm doing like the fans and stuff. So maybe you're right. Maybe one fan is enough. I don't know. I need to test it. I mean, you tried that motor. What do you think? Let's do. I'm not gonna add the additive box because I don't know. Sometimes it's you need to move it around a lot. So maybe we'll do this centered rectangle here at the center. Make this one our electronic box params dot fan width, and then this one electronic box params dot fan length, and then we just pad it using our height. Cool, so that's our fan. I ran my for several hours today, didn't feel any heat at all when I touched it, but mine is in open air, and I'm guessing in Sweden it's not that hot, right? I mean, for us I think it's like 26, 27. Sometimes it will hit the 30, but that's just for like a couple of months a year. But there are some places where it's super hot, where it's always hot. Anyways, let's try with one fan, as you said. 24 degrees inside. Okay, so 24 degrees, and you ran it for a couple of hours, didn't feel any heat. That's nice. Maybe, as you said, it's the wattage, because this one is like how much? How many watts are you? I think I was using this one, probably it was too high, right? No, 4 watts. Yeah, 4 watts. Anyways, we'll try it with one fan and see what's gonna happen. So the origin is where? The origin is on the back side. Cool. So origin on the back side. So we need to move it this way in the position positive Y. We need to move it by general.width minus electronic box params.thickness and minus the tolerance. And I always forget to divide the width by 2. I think you will be fine with one fan. Yeah, let's do one. I still don't know where to place the exhaust yet. But this fan is probably gonna like it's gonna hit the motor. Like the air is gonna hit the motor, and then maybe the motor will block this. But will this even generate heat? It has a heat sink, I think. Yeah, it has multiple heat sinks, so it should be fine. Yeah, I think, as you said, I think one fan blown directly on the motor should be fine. Now we need to move it up by general.height divided by 2. And in the X, we can move it by, I can put it in the middle, but I also want to make sure that it's blowing on. I want to make sure that's blowing on the motor. Yeah, I don't think that's an ideal position because the motor is probably going to be here. So maybe we need something like a fan offset from motor or something like that. Whoops. Let's set it to 10. So basically, if I clear this, set it to 0, I need to first move this to here and then move it by the offset. So that's gonna be electronic box params dot fan. Which one was this? Length or width? I think it was width divided by 2 plus interesting. So that's minus this entire thing. Cool. So now I can move this way by changing this value. My speed controller wasn't taught either. I think your has heat sinks since it's rated for 120 watt. I guess you will have less than 1/10 of that heat development. Yeah, exactly. This is rated for 120. We're basically using what? We're using 2 watts. And this on its own draws 6 watts. So that's nothing for it. Fan width. Okay, cool. The fan. Okay, I'm tripped. This is trippy. Let me put this here. Nice. Nice. It's looking nice. How are we gonna attach the fan? I'm guessing it's four screws, right? $10 mil, 10.7 mil. 10.7 is the height. So this is 10.7, I guess. Do you have any more dimensions? Wait, what is the noise level? 22 decibel. And by the way, how are we gonna connect the fan to do I just plug it directly to the power supply? It's gonna be on all the time, right? I mean, I guess I can do that. It's just positive, negative, so 40, 10 fan dimensions. It's 32. Okay, 32. So right here, where is it? We need to draw a sketch on the electronic box. We need a datum plane for that, I'm guessing. Yeah. So we need a datum plane attached to XZ. And then in this direction, it's gonna be minus general.width divided by 2. So now we have a datum plane on this face. We can create a sketch. Why is it always the other side? It's always like this. We need to draw a rectangle here. Now we need to... That's a bummer. 1 second. I didn't include the tolerance, right? Because this electronic box is moved by its tolerance. Interesting. So the distance from here to here is going to be electronic box dot fan offset from motor plus is it on it exactly? No, because I need to remove a tolerance. Okay, I got it now. I got it. So that's gonna be minus general tolerance plus, or wait, no, let's leave the tolerance. Let's leave it, and then we'll edit the fan. So this is going to be the fan width divided by 2. Cool. And all of these are going to be construction geometry. 1 second. Fan 1 has a position on the x-axis, and this one must have a tolerance. Okay, so here 32, we need to define this. So fan hole distance 32. So all of these will be equal. Wait, what? This one and this one are equal. Okay, cool. And this will be fan hole distance. The rectangle could be circular, right? The fins are round. You're talking about this? We'll check it. Oh, you're talking about the hole. Okay, wait. I'm not creating the hole now. Just 1 second. I'm creating the screws, the screw holes. Maybe did I say hole? Fan hole distance. Probably screw hole distance. I should also modify this. It should not mess with this. Screw hole distance, okay. Cool. Yeah, that's on me. That's my bad. So the distance up is going to be general dot height divided by 2. Okay, so now I have placements. I have 4 placements for the holes. So I can just take a circle here, 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 and here. And we need to select all of them, make them equal. And what type of screws do they use here? Is it mentioned? 3.5, and I'm guessing this is for the hex nuts. So 3.5, so basically that's a 3 mil. So fan screw diameter is 3. They use a 0.5 tolerance. Wow. Or let's make it 3.5. Fan screw hole diameter plus general dot tolerance multiplied by 2. 3.9. Cool. Now I'm going to create this circle, and this is gonna be, how big is it gonna be? Is it a 10? 40? Do you have the radius for it? It's 38.2 plus minus 0.3. That's like our tolerance. So 28.2 is gonna be the fan hole diameter. 38.2. Oh, my camera is off. I forgot to put it on charger. Give me a second. Come on. Okay, did it work? I think it did. Okay, cool. Fan hole diameter plus tolerance. Nice. So this, we can pocket it in one go and go to first. Cool. So we have the fan, we have the board. We still need to cut out. We need 2 cutouts, but I don't have the dimension of the second one. I only have the dimension of this. And this, I'm not sure how it's gonna stay in place. It's 21 by 15. I think, did I put it here anywhere? Yeah, 21 by 15, the switch. Oh wait, no. We don't have a datum plane here. We have a datum plane there. So we're gonna do another origin, datum plane on the XZ plane, and this time it's positive Z, so that's width divided by 2. Okay, I think I got what you mean. So this is removable, right? It's like a screw or something. And then I can insert, yeah, here's the nut. So basically I just need a hole. I need the circular hole, and that's it, right? Did I close this? Okay, cool. Let's see how we're gonna put these. Before we do anything, let me add a couple rows here. Let's call this one the let's call this the knob, and here we have a knob diameter. Let's say it's 5 mil, or knob hole diameter to be specific. I'm losing my voice, I don't know why. By the way, we still haven't figured out a way to attach this to this, but that's for later. And I also want to know where to put them. Here. I'm guessing I will have some sort of an offset maybe from here, or an offset from top. So put them in the center, but offset it from the top. Let's see. So add another row below. Let's say knob offset from top, something like 10. And switch also. Maybe also 10, and maybe another offset. So basically it's like coordinates. So I offset it from here, and then maybe I also offset it from here, and I can move them around however I want. Insert one row below, or no, we can do it in one sketch. We can do both of them in one sketch. This way we have like a defined distance between them somehow. Offset from top. So let's call this, let's do the switch offset from start, and then knob distance from switch, something like this. Let's say 25, and let's say here also 10. So yeah, I want to do them in one sketch. So we're gonna do something. Okay, cool. Cool. We need a rectangle. I think we need a regular rectangle, not a centered one. And a circle. So this is going to be electric. no, electronic box dot switch width, but we need to add tolerance. I always forget. So plus general dot tolerance multiplied by 2, and the electronic box dot switch length plus general dot tolerance multiplied by 2. Oh wait, maybe we did need a centered rectangle. Here's why. We can still do a centered rectangle. So if you want to convert a normal rectangle to a centered one, just add a point somewhere and take these two and the point and make them symmetric. And now you have a centered rectangle. So now we can take this center and this center, make them horizontal. So they are on the same plane. This one is going to be on the same line. This is going to be the knob diameter plus tolerance multiplied by 2. Okay. What else do we need? We need the distance between the two. So if we take this and the center right here and do the distance, this is gonna be electronic box dot knob distance from switch minus the knob diameter divided by 2, because we're going from here to here, so we need to remove the radius. And then what did I specify as a distance? Something is wrong. I think it should be plus. We need to add, my bad. Yeah, that's 10 mil. 10 mil and we have 2.5 mil. Yeah, plus. I think offset from top is not needed for the switch. If I want them to be centered, so we don't need that. I'm gonna remove it. Switch offset from start. Wait, what did I do? I don't need this. So once we define the switch, we are fine. So switch offset from top and offset from start, we can define that. So this is gonna be the entire height minus electronic box dot thickness minus electronic box dot switch offset from top. Okay, cool. And offset from start is easy. It's just this. Electronic box dot switch offset from start. And we can pocket this now to first. Okay, maybe we can move it up a bit. So from top, let's make it 8. And I think I centered this. Maybe we can change where we put the board. I haven't added any holes for the board yet, but we need to add them. Also for the power supply, but not today, because it's 12, almost 12. But I'm happy with what we have at the moment. It's rough, I know. It doesn't have any fillets or stuff. Maybe I'll add them later. By the way, remember I told you, like, for example, I can't just come here and add fillets to these because it will not be parametric. They are resolving this. So if we go to, no, if we go to FreeCAD releases, I think, yeah, release notes. So they are developing version 1.0. It's currently under development and there is no release date, but one of the biggest thing that they fixed is the topological naming problem. So this is already fixed. It's merged. And lots of things have been merged also, like they are changing the UI. There are very big changes in the sketcher. Where is the sketcher? Like in sketches, now it's becoming more and more like Fusion. For example, this is a contextual dimension constraint. So similar to Fusion, you click D on the keyboard and you can constrain anything you want. Something like that. Or you, for example, you click the square and then you can constrain it before you even create the square. It's going to be fully constrained. And the offset. Imagine they don't have an offset tool in the sketcher. I can't select a sketch and offset it, but they added it. Looks good. Maybe mock-up motor to get a feel of the final dimension and distance to power supply and so on. Yeah, definitely. I think we have the motor dimensions. Where were the, yeah. We can definitely create it. We're missing a couple of stuff, like the diameter of this thing, but that's fine. That is fine. And we don't know how big these are, but I'm guessing it's like a 6 mil. So totally doable. $37 is the entire. So yeah, so we can assume it's 37 across all of this. But one thing we're missing, this L, they did not specify the L. So maybe that's something you can measure for me. Because I guess, well, oh wait, we have more dimensions in here. 37. Oh, we have the offset. The offset is 7. Nice. So I can change it right now. Where is it? Motor holder. Motor pin offset is actually 7. And this is 37. This is 31, I think. 31, yeah. Yeah, but what is this L? Oh, we have it here. Okay. Wait, what? L size, yeah. So L for 12 volt, 7 speed. I'm guessing it's this. It's 29. L is 29. Yeah, we have everything. We can model it. But again, not today. Maybe next Monday. And I hope by then I have... Yeah, I doubt it. 7 days. No, I doubt I will have this stuff with me. But we're gonna have like a rough mock-up of everything. Maybe we can refine these. Instead of having squares, maybe give them a bit more detail, but I'm not sure, we'll see. Yeah, anyways. Yeah, we need to also mock up this thing right here to also see how far back it extends. But I think that's all for today. Let's see how it looks. Oops, no. Screw, bearing. And so this is how it looks so far with only one platform. You can have as many platforms as you want. Again, I'm not a big fan of this thing right here. This might change next Monday, we'll see. And I got some springs to test here. So we're gonna attach springs from here to here to make it where are the springs? I think I ordered the most overkill springs ever. Instead of getting like regular springs, I got like stainless steel. It might break the plastic, I don't know. We'll see. What I can do is replace this with metal pins, for example. And that would actually make it more printable. I just thought of this. Anyways. Yeah, I hope you enjoyed this live stream. It was a long one, I think. How only 1 hour? No, started at 9:30. Yeah, it was long. So yeah, have a nice day, and hope to see you in the next video. Thank you, Matthias, for the comments and all the help. Thank you. Bye.